So first of all, thank you so much for being here. We really appreciate it. This is the third in our series of summer webinars. So if you joined us for the first two, thank you for that as well. And don't forget that we do have one final fourth webinar next week as well. So the webinar is going to be given by Dr. Steve Liang, and he is a professor at the University of Calgary. He's in geomatics engineering, and he's been working in SensorWeb for over a decade. He is also the OGC SensorThings API editor, which means that he wrote the standard we're going to be talking about. And finally, he's the founder and CEO of SensorUp, which is the company that is provides the reference implementation for OGC SensorThings API. So you're going to be getting a very expert look at what we're talking about today. So I hope it really helps you. So just a few housekeeping things. If you move your mouse around on the screen, you should see a little panel come up with buttons for Q&A and chat. If you have any questions, we're going to answer them live at the end of the webinar. So please just click on the Q&A button and put your questions in there whenever you like, and we will get to them at the end of the webinar. And we'd love to have your questions, so please give us those. If anything's wrong, if you can't hear anything or something weird happens, feel free to use the chat panel, and then I can respond to you while Steve is still giving the webinar. Okay, while we're giving the webinar, check the chat panel for the recordings link, the slides link, and also the link to code examples. I'll be posting those for you too. So that's all the housekeeping we have, so I'll turn it over to Steve.
Okay, thank you, Coro, for the introduction. So welcome back to our third webinar, Analyze Your Smart City. So the idea is this: OGC SensorThings API is not just a data standard. So it's not only serve you data through the API. It allows you some, very powerful query functions in this API. So hopefully today we use some concrete scenario to uncover these query functions. We introduced them in the past using more like a lecture type of a way to show you the how to use it. But today we show some concrete examples. Okay, so I think no need to talk about me and talk about SensorUp a little bit. So SensorUp sponsored today's webinar, and SensorUp provide the reference implementation for the OGC SensorThings API. And also, we are a proud member of Eclipse Foundation. We have a Whiskers open source project, and you might see something very exciting very soon from Whiskers. And then and OGC, we are a proud member for OGC. And also, we appreciate, we got some support from some very generous program, and like S3 Emerging Business Partner and the Microsoft BitSpark. And then actually, we are just accepted as a BitSpark Plus, a program member. So that gives us more than a lot of cloud time, so we can do something like at scale now. So great, and Tectera support. And news, we talked about this last time, and OGC adopts the SensorThings API. So just if you're first time here, it's right now, it's officially, right, a released, published OGC standard. And also last time we talked about we will release a OGC SensorThings height chart and data table library, and which allow you to do a chart with 1 or 2 lines of code, right? And so it's available at sensorup.com. So go there and check it out and use it. And we have the examples in JSVideo. So you can go JSVideo and just try it out. And then, yeah, it's available for you to use. And next one. And, we just give you some updates about what we're planning. We are setting up a air quality network in Calgary. As you can see, if you were here last week, you can see more sensors now. And then we add 3 more from the official sources. And then, and this is a very nice, it's a alpha, beta prototype for what we've been doing for the front end, but you can see a nice demo there. So just to let you know, this is what we've been doing. Interesting. This is the other way, to show you that we can do analytics, this air quality demo, and all based on SensorThings API. And also we plan to do this for the initiative in Taiwan called LAS. So they have a great data set, like thousands of sensors over there. So we're working with the community, and we're excited about this. By the way, actually, we have this initiative about spreading sensors to more than 120 countries in the world. And then, so it's just a dream. Some of us will have this dream. We think, okay, why don't we spread sensors and recruiting volunteers? So anybody who are passionate about sensors, IoT, and air quality. So we want to deploy the sensors for 120 countries. So if you're interested, feel free to let us know, and then I'll connect you to the group called LAS, and then we'll start from there. We'll provide you more information next time. Sorry, something just pop up from my mind right now, but this is something great things. Air quality, 120 countries. Okay, so before we start, there are some useful resources you can use. If you want to learn SensorThings API, OGC SensorThings API, and there's a playground you can use. That's a good interactive tutorial. And the second one is you want to try the SensorThings API, and then we have a sandbox, so a full-featured link you can use called Scratchpad. So again, it's there. So today, we'll talk about Analyze Your Smart City. So what will be covered today? First one, again, back to this data model, right? Data model is very important, so we can make sure it's working. Okay, it's a proven working. It's ISO standard. It's called SensorThings. It's called observation and measurements. And then we have 6 examples, but 5 scenarios. The first one is, let's do a pie chart for air quality readings. So you might think, okay, for example, I have sensors, and how many readings are good quality? I mean, air quality sensor, right? So how many readings are good quality readings? How many are moderate risk? And how many are unhealthy, right? So just, to know, I mean, in terms of percentage, okay? So that's the first scenario we're going to talk about. And second one is, let's say we have sensors. I want to compare the maximum and minimum reading of that sensor for the past week. So how to do that with SensorThings API? That's the second one. And the third one is comparison, the air quality, what's the worst air quality of each station in the past week using a bar chart. So that's the third scenario, and how to use the OGC SensorThings API to do that. And the fourth one is show me all the air quality sensors within certain distance from a location, like a buffer. Show all air quality sensor with certain distance from a location. And finally, I want to show all the air quality sensors. They are not within a polygon. So it's, the first one, the one previous one is show inside this circle, right? And this one is outside of a polygon, right? It's a typical geospatial query, topological query. But again, to show you that how to do this in the SensorThings API, and these are all built in. Okay, next one. So I mentioned that every time I will do a talk about why should you use a open standard to build your IoT application. So today, the reason is future-proof and proven working. So you have 2 choices, right? If you want to build IoT application, you can use the existing open standard, or you build your own. And when you build your own, you have this risk of you do not leverage the years of R&D efforts from these open standard organizations, right? Our standard working group, we discussed this for 10 years already, right? Since the SensorUp time. And then so our model, the data model and the API actually is really working, has been used in real world, and it's proven working. So it's really, if you use open standard, really significantly reduce your risk, and you leverage years of R&D. And third one, maybe the most important one is you join this community, which is building an interoperable and global scale Internet of Things, rather than you are building your own silo and your own, unless you think you can build a global one by yourself, right? So this is the other reason. You should consider using open standard to build your IoT, okay? That's the reason for today. Okay, so dive into a tutorial. So today we'll be using SensorUp's air quality monitoring system in Calgary as an example. And so the link is below. So you can see more sensors there right now. And then as an example for today's tutorial, what do you need? You need any text editor, you need a modern browser, in this case with Chrome, and JSON view in this webinar. And this time we have an improvement. Actually, all the source code has been available on GitHub. So you know what? Go to this link, github.com/sensorup/webinars, and go to the webinar. The source code is there available. You can even download it and try it on and start hacking, right? Change it on your own computer. Okay, important, again, today we'll be using highstock.js today, and the library is open source. However, it has a pretty restricted license, so it's not free for commercial users. And highstock is a very powerful library and maybe the most popular libraries on the web right now, I mean, for the chart. So just let you know, I mean, there are some constraints there. Okay, again, acknowledgement. Thanks to Marianne to preparing today's source code. Good job. Okay, data model. This is the SensorThings data model. So the most important thing, let me get my mouse cursor. Okay, the most important thing is the thin. So today thing is just like last week, airbox. It's a box for sensors to monitor air quality. And then you have data stream, and we have associated metadata for this data stream. So for sensor, for example, we have the two sensor, plant tower, DHT22. And for observed property, we have three different observed properties. PM 2.5, that's the particulate matter, and relative humidity and air temperature. And then, so finally, the data actually are called observations. So observation has a result, has a phenomenon time. So what the time the phenomenon was observed, and then the observations has the target, which is a feature of interest. For example, for the sensor today, the example we'll be using is the sensor in my backyard. And then, so the backyard is, so the location of sensor is my backyard. And the target is the feature of interest is the air in my backyard. Okay, so when we talk about analytics, today we're talking about analytics, right? So I'm a professor, so let's talk about, let's find a framework, right, from a textbook. So there are steps to do analytics, right? Or we call it the data mining steps. If you go any data mining textbook or machine learning textbook, and this is the first chapter, right? These are the steps. So if you want to do analytics, you need to involve all these 7 steps. So the first step is clean the data. Second is integrate data from different sources. And third one is select data you want to use. And fourth one is transform the data into a format or data model you can use and fill in the blank, this and that. Okay, that's before you can do any real mining or analytics. So step 1, 2, 3, 4. And actually for any analytics, actually, you spend most of the time doing 1, 2, 3, 4 rather than the sexy analytics. And actually, data SensorThings API provides you 1, 2, 3, 4. And again, okay, if you use your own proprietary thing, right, you have multiple systems, and do step 1 to 4 is very, very time consuming. But with SensorThings API, you can connect with multiple systems. And 1, 2, 3, 4 is like that automatically. You can integrate them from different systems in a snapshot. Okay, great. So that's where the analytics functions SensorThings can provide. So including selections like query. Okay, so let's go to our first scenario, which is this is the target. So on the screen, I'm showing you what do we want to do, and we want to do is, you know, for a given sensor and for all the readings from this sensor, I want to know how many are unhealthy, how many are moderate, how many are healthy readings. Okay, so naively, what are you going to do? If you're using a very simple data API or it's built on top of a simple like Amazon AWS IoT, what are you going to do if you want to do this? So first of all, you need to download all the readings. And then you download them and count how many are the naive solution, right? Count how many are unhealthy, how many are moderate, and how many are healthy, right? That's a naive solution. So let's think about it. How to use SensorThings API to do this. I'll give you 2 seconds to think about it. And actually, we can use 3 different calls, and each call is very, very efficient, and you can get to generate this pie chart. So here we go. So in order to know the ratio of these ones, right? So 1.12%, 4.2%. Basically, what we need is number of good results divided by number of all results, right? So what do we need? We need the count. So same thing apply to moderate result, apply to unhealthy results. Yeah. Okay, so the second step is want to know what does it mean by good. So in this case, the air quality sensor we use, we collect the PM2.5 value, and we need to convert that into the air quality index. And because air quality index, AQI, is about good, moderate, and unhealthy, or very, very risky, yeah, something like that. So let's use that. So today, actually, I found for anything below 13 is good. Anything between 13 and 35.5 is moderate. Anything above, the reading is above, greater than 35.5 is unhealthy. Yeah. So that's the definition of the risk. Okay. As a result, the task right now is get a number of unhealthy readings, and that is greater than or equal to 35.5 from OGC SensorThings API. So how to get that from our API? Here's the query. So let me get my mouse cursor back. So look at this. So you have your endpoint here. And this direct to the observations we're interested. If you don't know this URL pattern, and review our previous webinars, but this is a RESTful. So that means this data stream, okay? And we want to know the observations. And here is the filter. So we can use a filter to filter the observations of this data stream. And the filter is, so show me the result greater than or equal to 35.5. So for example, let's let's go here and do this query. Voila, it gives you the readings. Actually, there are 7 readings and shows unhealthy. And then these are the readings. Okay, however, today we only need the count. We don't need these, actually. We don't. We only need what? This. So that's save some bandwidth. So we have something very interesting we can use is, for example, top 1. In this case, I only get the largest one and a count. And count is the thing I need today. As you can see, you can save a lot of bandwidth by doing this. Okay, so go back. So by adding top 1, we save some bandwidth and we can get the count we want. We don't need to go through all the readings, right? Like the naive solution that I mentioned. Okay. So the second step, we get the unhealthy ones, right? Let's get the modest one. So that's between 13 and 35.5. And then how to do that? Here is the query. Let me get my cursor back. So here's the URL pattern leading to the collection observations. So in this case, filter is, let's get the result less than, LT is less than 35.5, and the result is greater than or equal to 13. Okay, so you get that in between. And so as you can see, SensorThings API is very, very expressive, very powerful, expressivo. And then top 1. Okay, so in this case, for example, let's say the result less than like this. Yeah? And if you do this without top 1, you get lots of them, right? The first 100 as the service-driven pagination, but what you can get is this 252. That's all you need for this scenario. And of course, if you use top 1, you get only 1, and you get the largest one in this query, and then 252 is what you need. Okay. So at the end, you get this. So let me show you. Yeah, you get this. I can show the source code how to do this, and actually this is source code on GitHub. Okay, so basically we've sent 3 different queries using jQuery and JSON, and then so that's the query I just show you, and the third query show you, and these are 3 queries I show you. Yeah, and then let me refresh it. I think I committed. Oh no. Anyways, so these are 3 queries. And this source code I haven't, there's no top, but I'll put a top later. Okay, so make it more efficient. And then this is all you need, right? So for the total readings, you can get total readings and IoT.count. That gave you the count. So how many readings, right? And so on and so forth. So you can get the count for moderate reading, the count for unhealthy readings, and you feed into your pie chart, the high chart. It's a high chart here, a pie chart here, and voila. So you get this, okay? And you have time to look at source code. But we show you the how to get that very efficiently from SensorThings API. Okay, that's the first example. Hopefully you find that something useful and very efficient instead of you counting and go through all the readings, right? Okay, the second example, that's fine. Let's do a chart like this. So we have a chart and we have 2 line graphs. So the first line graph is the daily max, and the second line graph is the daily minimum temperature of the past week of certain sensor. So that's the temperature in my backyard. As you can see, let me show you an example then. That's my backyard. Okay, and you can see right now it's pretty cloudy, so the min and max is very close. But you know, like yesterday, it's very hot. It was very hot in Calgary, actually, 30 degrees. But it's pretty cold at night at 12. Anyway, so this is our target. What want to do today? So how to do that? So first step, get today's maximum temperature. Okay, so get today's maximum result value. So get observations on August 16th. Okay, so the first step is you get observations on this day. So that's the first step without talking about minimum or maximum, okay, of this day. So how to get observations, all the observation of a certain date. In SensorThings, we have this function. It's called day and month. So look at here. So you have filter, okay, and day function. So that means this returns you the day of the month of this phenomenon time equals 16. So that means give you the 16, okay? So if you without the month, it will give you every 16th, the data from every month 16th day, okay? So only this give you just day 16, okay? And then you can further filter, okay, to get the month, which is 8. So this give you the data on the 8th month of the year and the 16th day of the month, okay? If you have the data from multiple years, and this is great for you to compare the data from the same day of multiple years. Get that? Hopefully you find it very, very useful, actually. Yeah, it's just one line of query. You can compare like just that day, right? In the past. I don't know how many years, depends on your data. But we don't have multiple years today. So in this case, we just get August 16th, okay? However, what we want is just the maximum and minimum value. Of course, naive solution, you can get all the data, you find the maximum and you find the minimum, right? But it's very, very consuming bandwidth, right? So the next step is we want to get observation on that day with the largest value, okay? So how to do that? So we have this already, okay? And let's keep filter it. So how to do the maximum? Actually, if you think about it, maximum basically means when you order all your data result, okay, in a descending order, yeah? So descending order, so it's getting smaller and smaller when you go down. And then the top one is the maximum. Does it make sense? Hopefully it makes sense to you, yeah? So here is, we order all the readings on that day, and then with a descending order, and we only want the first one, yeah? And that's a maximum value, okay? Maximum, the observation with the maximum value, result value. In this case, we also use select, so that give you only 2 property spec, so result and phenomenon time. So in this case, let me show you, let me copy it, this. Voila, this is the maximum value. So you can get the maximum value, again, with one line of code. So hopefully you can apply this to minimum as well. So what will be the minimum? How to get the minimum? Just change the way you order it, the sorting, right? So in order to get the smallest result value, and basically just change this, So from descending order to ascending order. So the first one, top one, becomes the smallest value, right? Hopefully you know how to use this right now. Sounds good. And let's go to the code. So here the code. So demo2.js. Okay. So as you can see here, here's the query we send, and it's give you the minimum and the maximum value. And then we have a loop. By the way, this is this code. It changes according to we didn't hard code the date, right? So you always get the maximum minimum for the past week. Okay, so there's a loop. You get the current date and the loop to go through the past 7 days and give you the result back. Okay, but this is the query you send and the second query you send, and then here is basically to prepare the data for high chart, and here's the high chart. Okay, so the end result becomes like this. Sounds good. Hopefully you find it's the code is pretty simple and very efficient. So reuse the same code to get the data, but just change the high chart configuration. You can get the chart like this. Okay, so this and that, the same code for get the data. Okay, for OGC SensorThings API, that's the same code, but this is just different presentation. Okay, so it shows you the min and max from the past week. Okay, hopefully you find it useful. So that's our third example. I won't go to the source code. You can read by yourself. Okay, so that's the third one. Okay, the next one. So the next example is plot the worst air quality of each station in the past week. So how to do that? The first step is, because in order to get the worst air quality, we need to know what station are available, right? Because it will change. New sensor might join SensorThings API. So the first one is get the list of stations. So this is the code, how to get the list of stations. So here, but our interest is the air quality. And air quality, what does it mean by air quality? That means the sensor are monitoring an observed property. That observed property is called air quality. So for example, if we go here, demo 4, here, like this, let's just get the observed property. That's the observed property to here, okay? So PN 2.5 particularly, PN 2.5 basically, okay? And then if we keep expanding it, so thin data stream and thins. So it gives you the thins, which is the sensors, which observing or provide observation about this observed property. So give me all the sensors for this air quality. So this is the query to do that. So give you the list. So when the service, they generate, they have a new sensor join in, right? It doesn't matter. Our code should still working. Okay. And the second one is we have the list of the sensors or the things. And the next one is get the worst air quality result from every data stream from those things and observing air quality. Yeah. So here's the code. Is when you get these things, data streams, okay, and then we follow navigation link to their observations, and we filter, so the date and month, okay, for that day, right, of interest, and then we order by result, descending order. So we just show that to give you the maximum value, and maximum in terms of air quality is bad, the more the worse, right, and then select result and phenomenon time. Okay, so we know that, show that the previous time. Okay, so what's the result? The result is something like this. So we get the list of the stations and then use a very similar code like the previous one and get the worst reading and put them in the chart. Okay, so we get that. So yike. So yeah, somewhere doesn't have very good air quality in the past 2 days, or just that reading is not very good. Okay, the green, which one's my home? The red one is my home. It's okay, yeah. So that's just show you how to do that, okay? And again, the source code is here. So that's JS source code number 5. Oh no, number 4, right? The same source code. It's very, very similar. Okay. Yeah. Next one. Find all air quality sensors within certain distance from a location. That's very, very common in any GIS, and SensorThings API give you automatically give you that with again one line of code. Okay, so how to do that? So we use filter again. In OGC SensorThings API, we have something called geodistance. So to give you distance from 2 points, yeah, 1 point to the other point. So here we want to know the locations. Okay, so basically this is the point. Okay, let's say, oh, this is the point, and then this is the location of a thing, and then this together returns you the distance between that point into the location of the thing. And then our filter is we find the locations, and the distance is less than 10,000 meters. So 10,000 meters is 10 kilometers. Yep. So find the location, find all the locations that's within the distance from that point. The distance from that point is less than 10,000 meters. Okay. So that's basically give you the sensor within that circle. And after you get that, you can just plot on the chart, right? Plot on the map. And then because, sorry, I'm here. Okay, great, it's here. And we are using, because actually SensorThings API using GeoJSON as the location feature. So actually it's very, very easy. When you get the data, the list of the locations, you just simply parse it. Okay, so get the location and throw it in the leaflet and then add to the map. Voila, it's there. Okay, and then at the same time, I also draw a circle on the leaflet. So you have a circle, you know the query, and then you know the location data. So let's see the example here. So basically, this is the example. Okay, we send the query, and we get these 4, and we plot on the leaflet. And let me show you the query. Maybe we can see the query. So the query will be like, okay. So the query will be like, example, the stream, filter. Let me find the query here. That is a good opportunity to show you the query. So here's the query. Where to find it from the source code. Voila, and copy and paste. Voila. So this is the data returned from the SensorThings API, right? So give you the location within the distance of from that point. Okay, and then here is the example. You plot it on the map. Okay, sounds good. And it's very simple, very useful. However, today we'll go something even further. So let's say I have a polygon, and I want to get locations, the things, locations outside of this polygon, not within this polygon. Okay, how can we do that? And if you are familiar with GIS, it's with topological queries, right? And then this is called disjoint. So in SensorThings API, we do provide those topological query. So for example, find all sensors that are outside of a polygon. Okay, so here example is, this is my query. Okay, I find everything outside of this polygon, which are these guys. Yeah, there are a couple here. Okay, so here's a query. Basically is a different filter. The filter is to find location which is disjoint. Okay, so locations which is not inside of this polygon. Okay, and this is the filter we can use. If we go to the, I can show you the list of filters, the topological query filters. in OGC SensorThings API. So we have these filters, topological query filters for SensorThings API. So not only you can do disjoint, we can do like touches, right? So any sensor touch this boundary, yeah, and then it's within as well. That's a pretty very useful or common query: overlaps, crosses, intersects, contains, right? So these are all available in SensorThings API. So just let you know. And in this case, which will show you the query result, which is the location of the sensors outside of this polygon, okay? Okay, so all the source codes are available on GitHub. Go, fork it, star it, and go crazy. And that's today's tutorial. Hopefully we uncover some of the query functions for SensorThings API, and then show you, and we provide the source code and show you how to use them. And then next week is put everything together. So build interoperable smart city application effortlessly. So actually next week we're going to show you some libraries we've been working on and how we put them all together. And then so you don't even need to write those code. We just put them together with a few lines of code. Why can we do that? Why can we have a generic library for this? It's because we are following the OGC SensorThings API standard, and these libraries will be working with any compliant implementations. Hopefully you find it useful.
So I'm going to go to the first question. So first of all, we have some questions about to what extent the OGC SensorThings API standard is a geosector standard or a true world standard. So will this standard be accepted or adopted by the greater IoT community outside of the geospatial domain?
Great question. And as you can see, actually, SensorThings API can be used for outside of geospatial domain. And right now, the IoT world I mean, there are so many IoT platforms out there, and everybody think they can do a proper one, but most of them are wrong. And I don't know. I don't know how soon it will consolidate. We start to see there's consolidation happening right now. And I think it depends on us, everybody, to promote the standard, to not only in the geospatial world, but outside of geospatial world. You know what? Location is #1. It's a first-class citizen in Internet of Things, okay? And then you should leverage what we have been doing the work in the past 10 years, okay? It's our responsibility to promote to the world, because actually, if we don't promote, and how do they know? And however, we start to see very good adoptions around the world. There are different nations looking at the standard SensorThings API. There are pilots everywhere in different continents going on, and we receive a lot of interest from government bodies about this API. So actually, I think, in my opinion, OGC SensorThings API very possible will become the fastest adopted OGC service implementation standard. Yeah, compared to other service implementation standard. And normally the data model standards, they got adopted more, in a short period of time, but not services. But I think OGC SensorThings API have a very good possibility to be adopted very soon. And that's why we have this webinar. We have a lot of interest from all over the world, and I think it'll be relevant. Well, but everybody, we should promote this great API. Next question.
All right, so the next question is, what are the chances that IoT device vendors are going to support the OGC SensorThings API standard in their products?
So the question is, because, think about it. If you want standard to be popular and everywhere, the sensor makers or device makers, they have to support our API, right? I talked to several OEMs, big ones, yeah, in Asia, and then they say they are standard and API agnostic. As long as there are needs, they will support it. So as long as the clients say they want a SensorThings API compliant, they will do it. It's not difficult for them actually, especially OGC SensorThings API. It's pretty easy for the sensor makers to adopt. And then so again, it's about demand. But I think we start to see demand pick up, right? And then like today, WMS are everywhere. So very possible they will support. And then it's really about demand. So, okay. Next question.
So the next question is, as for geospatial queries, how does OGC SensorThings API handle Z values? Is XYZ coordinates supported? So that's vertical or third dimension. How does the CRS datum and projection support?
I think that's a great question. So GIS question, right? Right now, we use GeoJSON as the first location encoding, okay? And GeoJSON supports Z. So I think we can support Z, no problem. But again, the future work for SensorThings API is we support multiple geospatial encoding, okay? And then maybe include CDGML, maybe include moving features, OGC moving features, right? And then so definitely it's extensible enough to support those. And we would love to hear different use cases from you guys about different geospatial use cases, right? Let's go crazy here. Yeah, this is great, but definitely it's extensible. Allow us to do that. Okay, next question.
All right, so 52 degrees north implementation of OGC Sensor Observation Service allows creating an O&M data model on top of PostGIS. Since SensorThings API is also based on O&M, can the same or similar kinds of databases be used with OGC SensorThings API?
Okay, great question. Actually, I did a webinar about comparison of SensorThings and SOS SaaS. So that webinar, if you're interested, so go to that webinar. It's a very detailed explanation. So the question, yes and no. So yes means from SensorThings, OGC SensorThings API to SOS is very, very easy. Actually, our implementation support that. You can get SaaS from SensorThings. So SensorUp implementation supports that. Because the functions provided by SensorThings API is more than SaaS. And SaaS is a subset of SensorThings API. For example, we can, in SensorThings API, we can do this cross-linking from data stream to theme back to data stream. Okay. However, SaaS is not, it's hierarchical. So as a result, it is yes. So from SensorThings, you can go to SaaS, but no is you cannot go from SaaS to SensorThings. Next question.
So, one of the analyses which is of more interest is the interpolation or extrapolation of sensors data. So does OGC SensorThings support these functions?
Not at the moment. It wasn't in our core requirement when we designed the API, but doesn't mean that it cannot support. So welcome you to join the SWIG standard working group meeting, and then we can, we can vote about the priorities, right? We should do that. Vote about priority to do that. Okay.
All right. So did we try connecting SaaS services to SensorThings API?
We try to harvest the data from SaaS and put into SensorThings API. Yes, in that sense. Okay. And we have our own SaaS implementation as well. And then we know it's not doable. So to reuse the database to go SensorThings API. And then, yeah, so hopefully it answers the question. It's quite a detailed question. Yeah. Oh, next. Okay, final. Next question.
So the EU Inspire promotes SOS, but maybe they should go for a SensorThings API.
Yes, they should. They shall. And actually, they are looking at it now. So it will come. It will happen, actually. Yeah, it will happen.
Thanks so much for coming, everybody. Thanks so much for all your questions, and thanks so much for answering the poll. If you need the links, there are links to the recordings, the slides, the code examples, the developer center, the playground, and the sandbox, all in the webinar chat, which you can find by wiggling your mouse and clicking on the chat button in the window. And please don't forget, there's one more webinar in this series. It's next week, Thursday, 11 at the same time, so 11 Mountain. Have to translate that to your time. And please share it with anybody you think might be interested in coming. All right, thanks so much for coming, guys. We'll see you next week. Bye.